Hello everyone, welcome to my channel. I'm Tepin and you're watching Tepin's Lab, and today we're going to talk about some queries that you guys have posted in my channel. Not all of them, but these two actually, because they are almost similar, and that is how to incorporate the methods that you guys have learned from my lessons into writing for journal publication or in the materials and method section for your research article. So I'm going to show you because currently I'm also writing some papers. So this is the paper I'm writing. So in here, I'm not going to cover all the things here. I'm just going to show you the part that is important and the part that I made lessons on. So first, of course, DNA extraction and amplification. So this you will be doing by your own with different methods following. Phylogenetic analysis were generated using ITS sequence data. So in this case, I've only used ITS sequence, and the gene bank sequence were retrieved. So all the other sequence except from the sequence that I have generated were retrieved following these people, and that's given here. So not people, this paper, and then we have ITS dataset that was aligned using MA50 version 7 with scoring metrics for nucleotide sequence as given here. This is the option that you will find in the MFT website, and then we have default parameters and remaining default parameters. Okay, and remaining default parameters. The ends were trimmed. These sequences were used as outgrouped, selected as outgroup, and then phylogenetic analysis of the aligned dataset was done using maximum likelihood and Bayesian inference. So maximum likelihood was done for using this. You must know about this, and this was done using so Bayesian inference was done using Mr. Bayes. And Mr. Model test 2 was used for substitution model selection. The data matrices were arranged using Mesquite, and the sequence alignment and biosynthesis tree were deposited tree-based. So I have not made lessons on this part, but I will make it as soon as possible. But for now, let me tell you about this part. So we have used this software and this software. This is for maximum likelihood and this is for Mr. Base. And the substitution model GTRIG for ITS and LSU dataset were selected. So actually I'm not using this sequence here, so I'll just remove it. So this was selected for ITS dataset and was selected as the best fit substitution model. This best substitution model was selected as best fit substitution model according to AIC. So sometimes we use Bayesian information criterion, but this time we have used Geiger information criterion. So, and the Bayesian inference was done using substitution model as given by Mr. Model Test 2, means this model with two independent runs, each with 4 gens and 1.5 million generation for a 50% majority consensus tree. This I'm going to tell you now. This is actually, let me show you here. Uh, yes, here. So Bayesian inference was done using the substitution model as given by Mr. Model Test 2. So I've already made lessons on Mr. Model Test 2, how to select the substitution best fit substitution model, and then Bayesian inference was done using substitution model with two independent runs. So this is what Mr. Bayes does by default. Okay, by default Mr. Bayes runs two independent runs. So this you have to choose each with 4 gens. So we have made here number of gens is equal to 4, and then okay, sorry, and then we have 1.5 million generation. This we also have to choose. You can see here 1.5 million generation, and then 50% majority consensus tree. So this is what Mr. Base does. 50% majority consensus tree. It make a tree with 50% majority consensus tree, which also calculate posterior probabilities values. And the three were samples. This okay, let me explain quickly this about this. The 50% majority consensus tree and calculate Bayesian posterior probabilities means this when we do Bayesian inference using Mr. Bayes, so it actually give us this result. Gives this two as a result means 50% consensus tree with Bayesian posterior probability calculated by the Mr. Bayes at the node values. So that's what it gives. And we have three samples every 100 generation, and we have sample frequency, you can see here 100, and initial 24% of sample tree were burned, means you can see here burned in initial 25%. So this is how you are supposed to write. You can change the pattern of how you write, because you cannot just copy paste this one here. So you have to write in your own way, but this is how you are supposed to incorporate your methods. And after that, we have maximum likelihood was done following same model for each data set with 1000 bootstrap. So this is what I have done, 1000 bootstrap, keeping all parameters default. So in case of maximum likelihood analysis, I have done nothing other than changing the bootstrap values to 1000, and after that, nearly similar topologies were obtained in both analyses. Therefore, a single tree was presented with for both datasets in okay, not both of them, for the dataset in the current study with both PS and BPP values. Dataset phylogenetic trees were visualized and generated using Python. So this is what I've used for visualizing the tree. Branch node with 70% PS value and were considered significant. So this is what I consider significance. And after that, this is the taxonomy part. You don't have to worry about that. And this is the phylogenetic phylogenetic result. The final ITS data set had 733 characters with 94 taxa. According to Mr. Soab, used 94 taxa. According to model test, the substitution model TTRIG was selected as best fit model substitution based on AIC and nearly similar to tree topologies. Therefore, single tree has been presented in current study with both PS and BPP values with more than 50% and 0.5 respectively. So this is the phylogenetic part. You can also see this one in other analysis. This is also a paper from Fungal Diversity Journal, and I'm going to show you here. Same thing. This paper have used dataset ITS analysis in T8 region, analysis and many other regions. So they have aligned all these DNA region separately using MAFFT under this option. This you will find in the website, and then concatenated as a single alignment, and then they had concatenated as a single alignment, and then it was deposited in the tree base. So best fit evolutionary model of each alignment was estimated using J-model test. You can see J-model test was used for best evolutionary model under AIC. You can see here, and following the best evolutionary model of alignment, phylogenetic analysis were performed using maximum likelihood Bayesian inference. You can see here, following the best evolutionary model means The best evolutionary model as given by the model test, they've used that one to uh, perform maximum likelihood and Bayesian inference method for phylogenetic analysis. And then the maximum likelihood was done using RoxML GUI, sorry, RAXML GUI 2.0, and with calculation of bootstrap replicate under auto FC option. So they have used auto FC, not 1000 bootstrap. And then we have Mr. Base with two independent, you can see here, two independent runs, each with 4 chain and starting from random trees. Starting from random trees means sometimes what we do is we start from a particular tree, for example, neighbor joining or other phylogenetic tree. But in these cases, we have not used any kind of that type of trees. So this is starting from random trees. And trees were sampled every 100 generation. This I have already told you. And the first 25% were removed as burning. This I have already told you in my previous um, previously. And 75% trees were retained for constructing a 50% majority consensus tree. This also I've already told you. So remaining means the remaining 75% were used for constructing 50% majority consensus tree and calculating Bayesian posterior probability. And 10 convergence was determined using tracer 1.5. So this I have not made any lessons on this one, but quickly I will tell you about something about this one is that when we do Bayesian inference analysis using Mr. Base, number of chain we have are 4 chains with two independent runs with one with 10 million generations in this case. So that time when the number of generations are done, sometimes after a number of generations they are going to converge with each other. So many times they converge, how important it is, and all those things are traced by this tracer 1.5. So more on this one later. I'll make some video about this one also. And then we have the topologies inferred from ML method presented along with bootstrap values from ML method. So it just told us that the bootstrap values from ML went above 50% and Bayesian posterior probability when above 0.8 were presented in the tree, nothing less than them. So sequences were aligned using cluster X. They already aligned the sequences after the concatenation and then manually edited in bioinit. Prior to phylogenetic analysis, ambiguous region at the end and the start were deleted. Let me show you the tree, and this is, you can see here they have presented 100 bootstrap below and 0.1, 50, 0.92. So they have not presented more than 50. So maybe in this cases it was less than 50%, or maybe it didn't existed at all. So it doesn't matter. It was less than 50. That's what we know. And you can see here all of them. This is bootstrap. This is your Bayesian posterior probability. In this case, this is your bootstrap, and the Bayesian posterior probability is missing, means it is most probably it is most probably below 7, 0.7. And also you can see here tree maximum likelihood tree of, this is a maximum likelihood tree with this data set and bootstrap value more than 50% and posterior probability more than 80. Okay, so more than 80 is presented here. More less than 80 was discarded. So this is it. Thanks for watching, and I'll be dealing with all remaining For example, this and all this and this I'll be dealing in future. So stay tuned and don't forget to hit like and subscribe to my channel. Thanks for watching.